On this example, we're given three sides of a triangle, but we don't know any of the angles. That's the goal here. Solve this triangle, find all the missing angles. Then we'll have everything, all the sides and all the angles. So I went ahead and just drew kind of an ambiguous triangle here. Not drawing the scale at all, but I did label things. So alpha is going to be opposite A, beta is across from B, and gamma is across from C. All right, next, we don't know any of the angles, so we can't use law of sines. We don't know any of these are right angles, so we can't use any of the SOHCAHTOA or Pythagorean theorem. You know, any of these trig ratios won't work here. Those require right triangles. So we're pretty limited. We have to go over here to law of cosines. Now, these top versions, I like using these versions if I'm looking for one of the side lengths. These bottom three versions are just rearrangements of the top ones to isolate the cosine of alpha, cosine of beta, or cosine of gamma on one side by themselves. So we can kind of choose whichever one we'd like to solve for first, alpha, beta, or gamma. I'm going to use this top version and just solve for alpha first. So let's go ahead and say cosine of alpha is going to equal, well, we've got b squared, so 7 squared, plus c squared, 10 squared, minus a squared, 5 squared, all over 2 times b times c. So hopefully pretty straightforward, plug it in, just using the values given to us, replacing a's, b's, and c's over in our formula. Next, we've got cosine of alpha. I'm just going to do some reducing down next. So I know things like 7 squared is 49, 10 squared is 100, 5 squared is 25. And for our denominator, we can calculate 2 times 7 times 10 is going to be 140. Now, overall, we can combine together those numerators, and I think we should get 124. Oops, that was 140 in our denominator. All right, so we have cosine of alpha equals 124 over 140. I get that this would reduce down, but we're about to pull out the calculators anyway, so I'm not going to worry about that. I want to get alpha out from inside of cosine, this function, so I need to use cosine inverse, arccosine. And I'm going to apply this to both sides. That's perfectly fine to do because it's a one-to-one function. So each side gets plugged into arccosine. Left-hand side, we're just going to get alpha coming out. Nice canceling out if you want to say that. Over on the left-hand side, these are inverses. They do the opposite of what either one does. All right. And then on the right-hand side, I would probably just go ahead, put this in my calculator. If I want degrees to come out, I want to be in degree mode. So cosine inverse, that's second cosine to bring up cosine inverse or arccosine of 124 divided by 140. I got 27.66 degrees. Kind of label it over here in our triangle. All right, now we still need beta. We need gamma. We can use the law of sines at this point because we do have an opposite angle and side length that are across from each other. So we could use law of sines. Instead, I'm going to elect to use law of cosines again. Law of sines does have some setbacks with it, even though it does feel easier to memorize. Let's see if we can fill in here to the second version, the cosine of beta. And we'll solve for beta. So cosine of beta is going to equal a squared. So 5 squared, you okay with me saying 25, plus c squared, 10 squared is 100, minus b squared, 7 squared is 49, over 2 times a times c. So this brings us to, with a little bit of reducing down, we can say 25 plus 100 minus 49 is going to be 76. And then 2 times 5 times 10 is going to be 100. Pretty similar situation where we were when we had cosine of alpha equals 124 over 140. Pretty similar solving this down also, where we're going to apply a cosine inverse to both sides because beta is inside of the cosine function. So do it to both sides. 76 divided by 100 on the inside here. That'll give us beta is going to be, again, second cosine 76 divided by 100. Probably close some parentheses off there. I got 40.5358. I'm going to 0.54 degrees. I'll go to 2 decimal places, just like this first one we rounded to 2 decimal places. So 40.54 degrees. All right, the last one we need to find is going to be that gamma. Well, we could fill into the third version here for our law of cosines. Nothing wrong with that. However, once you have 2 of the 3 side lengths, or rather angles, we can get the third one pretty easily, as long as we remember that all the angles in a triangle have to add up to 180 degrees. So we start with 180. You subtract off the 70 or 27.66 degrees and the 40.54 degrees that we already found. So 180 minus 27.66 minus 40.54 is going to be 111.8 degrees. And another thing to kind of note when you get done here, biggest angle across from the biggest side length. Smallest angle, smallest side length. Across from each other, middle angle, middle side length, which kind of makes sense when you think about it. But a good thing to double check when you get done with these, just to make sure something didn't get mislabeled along the way, something like that. So I hope this helps out as you're working on law of cosines, trying to solve down non-right triangles. Good luck.